Multiple choice 9, sodium carbonate can be used to neutralise hydrochloric acid. The correct equation omitting spectator ions is. So what we have to do is we have to look at the product side. We look for the substance which has AQ, because AQ is a solution and solution contains the word ions in it, and that is our spectator ions. So we can score out our Na plus on both sides of the equation and our Cl minus on both sides of the equation. We then want to match that up to the example that we have, and we can see the correct answer to this is multiple choice answer B, as we have two H plus ions in the aqueous solution. We have a CO3 minus in the aqueous solution, and that forms water in the liquid state and carbon dioxide in the gas state. Multiple choice 10 gives us the shortened structural formula and asks us to name the above compound. So what we want to do is we want to take that out of shortened structural formula and draw the full structural formula. So we've got a CH3, a CH, the brackets tells us that we have a branch coming off of that carbon which contains the hydrogen. We've got a CH2, a C with two branches on it, and a CH3. What we then want to look at is the longest carbon chain. We want to number those 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 backwards. We want to look at the positions of the branches, and we can see that on the right hand side we have got two branches in that position, so that we want those to be in the lowest number. So we're going to be using the bottom row, and therefore the name of this would be 2,2,4 trimethylpentane. Multiple choice 11, the structure of 2-methyl-butene is given. Which of the following represents an isomer of 2-methyl-butene? So the first thing we have to know is the definition of an isomer. An isomer has the same molecular formula, meaning the same number of carbon and hydrogen atoms, but a different structural formula, meaning that the atoms are arranged differently. So the first thing that we want to do is write the molecular formula. So for 2-methyl-butene, the molecular formula is C5H5, and if we put those for the examples of A, B, C and D, we can see that we can eliminate B and D, as those two examples don't have the same number of carbon and hydrogen atoms. Remember, the second part of the definition, it's got a different structural formula, so the atoms are arranged differently. Which one can we see looks clearly different from the original? It would be C, which would be cyclopentane. Multiple choice 12, which of the following would not be produced by an addition reaction of butene? So if we look at butene's full structural formula, we can see that the middle two carbons, there is where the carbon to carbon double bond is, and therefore that's the position in which the molecule that we add across the carbon to carbon double bond would be in. When I take these shortened structural formulas out and draw them as full structural formulas, you can see that the only one which doesn't have the molecules added to the middle position would be multiple choice answer B. 13. Carboxylic acids can react to form compounds known as ketones. Identify the ketone that can be formed by reacting two carboxylic acids below. So this is a past paper question which is problem solving. What we can see is on the product we have a CH3 group and a C2H5 group. Looking at the reactants which formed that product, we can see that the first reactant has a CH3 group on the left hand side, and the second reactant has a C2H5 group on the right hand side. I've put a circle around the area which must have been removed to form that ketone. We're going to follow that pattern for the example given below, and we're going to match that up to the correct answer, which we can see is multiple choice answer A, which has our H5C2 group and the C5H11 group. Multiple choice 14, which line in the table correctly describes methanol compared to octan 1-ol? So we've got two headings here, which is formula, mass and solubility in water. So if we're looking at the solubility part of it, we need to know that methanol, ethanol and propanol are miscible in water, which means that they can dissolve. So the correct answer to this would be that methanol has a higher solubility than octan 1-ol. So the only answers it could be would be multiple choice answer C or D. We then have to look at the formula mass. Methanol has the molecular formula CH3OH, which has a GFM of 32 grams. Octan 1-ol has the molecular formula C8H17OH and has the GFM of 130 grams. So therefore, methanol has a lower formula mass than octan 1-ol, so the correct answer to this is multiple choice answer D. Multiple choice 15, which of the following is correct for both of the molecules shown below? You may wish to use your data booklet to help you. So multiple choice answer A says that they can both be represented by the general formula CnH2n. So the first molecule we have is an alkane, which has the molecular formula C4H10, and therefore would have the general formula CnH2n plus 2. The second molecule is a cycloalkane, has the molecular formula C4H8, and would have the general formula CnH2n. So they both do not have the same general formula, so A cannot be correct. They have the same melting point, so what we want to do is we want to use our data booklet, and when we look up the melting points and boiling points of selected compounds, we can see that butane and cyclobutane do not have the same melting point and boiling point, so B can also not be correct. If we're looking at C, it's talking about the solubility in water. Both alkanes and cycloalkanes are insoluble in water, so therefore that cannot be correct. And if we look at the molecules, if a molecule's family ends in ane, that means that it has carbon-to-carbon single bonds, and the term we use to describe carbon-to-carbon single bonds is saturated, so the correct answer to this is multiple choice answer D. Multiple choice 16, sodium methanoate is produced in the reaction of. So sodium methanoate is a salt, okay? And salts are made from a neutralization reaction when an acid and a base or alkali react. That's what we call neutralization. So therefore, we're going to be looking for the acid and the base part of the name. The first part of the name comes from the base, and we need to know the bases song, which is bases, they're so great, oxide, hydroxide and carbonate. So we're going to be looking for a metal oxide, a metal hydroxide or a metal carbonate. We can see that sodium chloride is not an oxide, hydroxide or carbonate, so B cannot be correct. And also sodium is just a metal, it's not a metal, oxide, hydroxide or carbonate, so D can also not be correct. We can see then that we also have to look for the acid part of the name, and the only one which has an acid in it is multiple choice answer C, sodium oxide and methanoic acid.